Class 12th, Subject Physics, 12th Chapter, Electromagnetic Induction. Electromagnetic Induction. From the chapter, let us see some of the formulae. First, induced EMF by Faraday's law. So, according to Faraday's law, the magnitude of induced EMF E is equal to d phi by dt. E equal to d phi by dt. Second, Lenz's law, which gives the direction of induced EMF, that is, according to Lenz's law, E equal to minus d phi by dt. E is equal to minus d phi by dt. Third, Lorentz force. Lorentz force. So Lorentz force F is equal to Q into phi cross B. F is equal to Q into phi cross B. Then fourth, maximum induced EMF in a conductor. Maximum induced EMF in a conductor. So the maximum induced EMF is given by the formula E max is equal to B L phi. E max equal to B L phi. Fifth formula is for motional EMF in a rotating bar. Motional EMF in a rotating bar, that is E equal to half B omega L square. E is equal to half B omega L square. Then sixth formula is for induced EMF. Induced EMF generated by a rotating coil of n turns. A rotating coil of n turns, and it is given as E equal to NAB omega sin omega t. NAB omega sin omega t, which will be further written as E0 sin omega t, E0 sin omega t, and that will be equal to E0 sin 2 pi ft. E0 sin 2 pi ft. Then seventh formula gives electric power P. Electric power P is equal to the dot product of F and phi, factor F dot factor phi, which will be written as B square L square phi into V upon R. B square L square phi into phi by R. So that will be equal to B square L square phi square upon R. B square L square phi square upon R. Then eighth formula gives the coefficient of self-inductance. Coefficient of self-inductance L is equal to E upon di by dt. E upon di by dt. Then ninth formula is for a solenoid. For a solenoid, inductance, that is coefficient of self-inductance L, is equal to mu 0 n square L A. Mu 0 n square L A. Then 10th formula is for inductances in series. Inductances in series. If L1, L2, L3 up to Ln are the inductances, and if they are connected in series, then the effective inductance L total will be equal to L1 plus L2 plus L3 plus and so on. L1 plus L2 plus L3 plus and so on. Then 11th formula gives the inductances in parallel. If the inductances are connected in parallel, then their effective inductance will be given as 1 upon L total. 1 upon L total equal to 1 upon L1 plus 1 upon L2 plus 1 upon L3 plus and so on. So 1 upon L total will be equal to 1 upon L1 plus 1 upon L2 plus 1 upon L3 plus and so on. Then 12th formula gives the energy stored in magnetic field. The energy stored in magnetic field U is equal to half Li square, half Li square. Then 13th formula gives energy density of magnetic field. Energy density of magnetic field UB equal to B square upon 2 mu 0. B square upon 2 mu 0. Then 14th formula gives the coefficient of mutual inductance. Coefficient of mutual inductance M is equal to E upon dip by dt. E upon dip by dt. Then 15th formula is for coefficient of coupling between two circuits. That is M is equal to K into square root of L1 L2. M is equal to K into square root of L1 L2 for perfect coupling of the circuits. For perfect coupling, K should be equal to 1. So as K is equal to 1, therefore M will be equal to root of L1 L2. M is equal to root of L1 L2. Then 16th formula gives the relation between the EMF of primary and secondary, the number of turns of primary and secondary, and currents in the primary and secondary, and therefore for a transformer we can write ES upon EP equal to NS upon NP equal to IP upon IS. ES upon EP equal to NS upon NP equal to IP upon IS. So these are some of the formulae related with the electromagnetic induction.